Okay, so we are live. This is video number 1 for sequences in L'Hopital's rule. So we're going to start out a little review here. The arithmetic sequence is it's the first term plus n minus 1 differences, where d is a common difference. Arithmetic means we're adding something each time. It's a common difference. A geometric is the nth term is equal to the first term times r to the n minus 1, or it can be this where it's the zero term, where r is the common difference, or common ratio, and then we use r to the n. Okay? All right, so if we look at this one, the first one, well, what am I doing each time? Well, I'm not adding something. I am multiplying by something, okay? And our first term is 6, so we know that a sub n, or a sub 1, or a sub 0, whatever you want to call it, is equal to 6 r. Well, I can take any term and divide it by the previous one, so I think this is the easiest one to do. So if I take negative 4 and divide it by 6, I get negative 2/3. Okay, so our formula for the sequence would be a sub n is equal to 6, because it is the first term, times negative 2/3 to the n. And that starts with n is equal to 0. Okay? All right. Well, that's really what this one represents, is when n starts with 0. This one here started when n was equal to 1. Okay? I prefer to write it with the n is 0 term. Okay, the sum, well, as long as r is between negative 1 and 1, the sum is a over 1 minus r. So if I take the first term, it's 6 over 1 minus negative 2/3. I get 6 over 1, actually plus 2/3, which is 5/3. So I get 6 over 5/3, which becomes 18/5. So if I were able to sum all of them, I would get 18/5. Ooh, I should have said the common ratio. That's actually what I should have done here. Was negative 4 over 6, so that would be negative 2/3 as we found. Okay? It's a common ratio because it was geometric. Okay? I guess I should have done that first. Okay, so our next one we're going to look at is another one. Well, if I look at this, I'm not multiplying by anything. It seems like I am adding something. Okay, so it looks like it's arithmetic, so I'm going to check. If I do 1/5 minus 6, I'll do the calculator version. So if I do 1/5, let's go home, minus 6, I get negative 29/5. I want to make sure that that is consistent. So if I do the next two, yep, that is negative 29/5. If I do it again, that's negative 29/5. So it is arithmetic. We have a common difference. I do it by subtracting here, and it's going down by negative 29/5 each time. So if I use our formula, our first term here was 6. And it's plus, well, since d is negative, we're going to do minus 29/5 times n minus 1. And that would be a, or b sub n would equal that. Okay? The sum, well, since it's an arithmetic sequence, the sum is infinite. Actually, it becomes negative infinity. Okay? Because we're always adding negative 29, so it gets more and more and more and more and more negative. Okay. So now we're going to look at the next one. So we're given the fifth, so the fifth term is 2100. The eighth term is negative 262,500. Okay, and this is a geometric. Okay, so we're going to find a bunch of things. We're going to find what the first term is, the common ratio, and the explicit rule for the nth term. Okay, well, first of all, I want you to think about, if we go from the fifth term to the eighth term, we're going to be, since it's geometric, we're multiplying by r each time. And how many r's will it be? Will we multiply by to get from 5 to 8 is going to be 3. So I'm going to do 2100 times r cubed, because I'm multiplying it by it 3 times, is equal to negative 262,500. So r cubed is equal to, it's cubed, is equal to negative 262,500 divided by 2100. Okay, if I do that, I get negative 262, whoops, bit of a glare, sorry about that. 262,500 divided by 2100, I get negative 125. Okay, so r cubed is therefore equal to negative 125. Well, what number times itself 3 times will give us negative 125? So r is negative 5. Okay, so that is our common ratio. Okay, now we need to find our first term. Okay, since this is our 5th term, we got to go back to that first term, and we know that going from the 1st to the 5th, or the 5th to the 8th, we multiply by our 3 times. Here we're going to multiply it by our 4 times, but we don't know what we're starting with. So it's some number times r to the 4th is going to equal that 2100. Well, we know r to the 4th. If I multiply negative 5 to the 4th, it's 625. If I get the box by itself, that's our initial value. I'm going to do 2100 divided by 625. And I get 84 over 25. So my first term is 84 over 25. Okay? All right. So what is our rule? Well, we're starting with this one, and we're multiplying by this each time. So therefore, if I call this a sub n, well, I called a and b, so I'll do this. C sub n is equal to my first term, which is 84 over 25, times negative 5 to the n power. Okay, and that is, if I do it this way, that is when n starts with 0, or I could say c sub n is equal to 85 over 25 times negative 5 to the n minus 1, and that starts when n is equal to 1. Okay, so it doesn't matter which version we actually do, we just have to be confident in doing both of them. So this one, I had to find r, and then I had to walk back to find their first term, and then go from there. Okay, then I can write it out. Okay, so our next one is a similar one, but now we're talking about an arithmetic sequence, I mean. So we know the 4th term is 8, and we know the 9th term is a half. So since it's arithmetic, is you realize to go from the 4th to the 9th term, I'm going to add d, or that difference, I have to add it 5 times. Okay? All right. So if I think about it, if I look at this, I'm going to do 8 plus some number d times 5 has to equal 1/2. Okay? I'm basically just using this because I got to get from one to the next. All right. So if I go ahead and do this, if I subtract 8 and divide by 5, I'm going to get what? Negative 7.5 over 5, which I believe is, so if I do negative 7.5 divided by 5, I get negative 1.5, so our common difference is negative 1.5. Okay? And I could add d 5 times, or I could just put 5 times d. So I know, but I don't know the first term yet, but I know the common difference, so that's d. So now we got to walk it back to our first term. Well, so I've got to go back 3 times with negative 1.5. So it's some number plus 3 times negative 1.5 is going to give me 8. Okay, so if I do the box is equal to what? Negative 4.5 is equal to 8. That means our initial value is negative 12.5. Okay? All right. So now if we look at this for any term, okay, so this, I'll call this d sub n, is going to be our first term, like what we had up here, which is negative 12.5, plus d, which was negative, or I'll make that a minus 1.5 times n minus 1. So if I want actually to verify, if I want to find my ninth term, okay, so d sub 9, we'll check it, is negative 12.5 minus 1.5 times 8. If I go ahead and compute that, oops, this should have been a positive 12.5. Sorry about that. Glad I caught it. So if I go ahead and do this, if I do 12.5 minus 1.5 times 8, I do in fact get a half, which is what we had in our ninth term. So d sub 9 is in fact 1/2. Okay? So I wanted to, all I did is I used my formula to verify that that was in fact true. All right, so I think we're going to finish the first page on this video, and then we'll go from there. So we're going to graph the following sequences and determine the limit as n goes to infinity for each. Okay. There is a sequence mode on here, which in many cases can be very helpful. So if I go to my mode, and I'm just going to go over and change to sequence, it's going to give me a better idea of what's going on. I'm hit enter to make sure I save it. So now when I go to y equals, I now have these really funky looking things here, and what they mean is this is our function and this is our first value. So our function here, I'm going to do 3n, and your inputs have to be n. Okay, and you could do this as a y equals also, but some of the graphs get really goofy. So if I do 3n divided by, and I do a parentheses n cubed, or n squared plus 3, sorry about that, n squared plus 3. Close it off, and my initial value here was, n was 1, so that's what I'm going to put there. Okay, and if I go look at the graph now, it's going to plot all those values. I want to go check out what my window says. So if I go to table set, I'm starting at 6 and going up by 1. Let's start at 1 and go up by 1. And then the other thing I want to do is go to my window, and let's go from all the way out to 100. That's fine. That's fine. All right. So if I hit graph, and now if I hit trace here and I start looking at values, if I trace along here, well, what does this look like it's going to? Each of those keep getting smaller and smaller and smaller. They never seem to get negative. Well, I want you to think about this. Is what is the limit as n goes to infinity? Well, the bottom is growing faster, so the limit of a sub n as n goes to infinity is in fact 0. Okay? So I graphed it in, I found what they looked like, because our graph of it, by the way, these are each little dots, and they're approaching 0. And that's really what this graph is doing, is it's plotting each of the dots. Okay, so if we look at this one, well, if we look, we can look at this one pretty easily and look at the limit as n goes to infinity of b sub n in this case. Well, they're both growing at the same rate, so we should get 1. So if I go, I'm going to go graph this, go back to y equals. I realize for these, we probably don't need to graph them, but I want to go ahead and take care of that, so you at least know how to do them, because some do get a little more complicated. So I'm going to do n, whoopsie, go back to y equals. I'm going to do parentheses n minus 5 divided by parentheses n plus 1. Now this one will be valid, or excuse me, defined for all values, because it's never undefined starting at 1. N plus 1. Actually, it would have been nice if I would have typed these in first. Okay, so now if I go look at the graph, if you look at that and we start tracing this, it actually starts negative, but if you look as we keep getting bigger and bigger and bigger, it is approaching a single value. And if I would keep going on forever and ever and ever, if you look at that, it is approaching 1. We're not there yet. We're clearly not there yet, even at 83. But we can look at the function and realize that ratio is going to go to 1. Okay? All right, this one gets a little tougher, and that's why we really want to make sure we graph this one. Okay? So I'm going to do, and let's go back to y equals, and I'm going to type this in. I got to be careful. Remember, I have to do n times the sine of 1 over n. Okay, so now when I hit graph, let's take a look. So we're worried about it as n goes to infinity. So if I hit trace, looks like we're at a single value pretty quick. Yeah, it converges to 1 very, 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 very quickly. Okay? But looking at that function, at the original function, it's very difficult to tell that this is going to in fact equal 1. Okay? We will have another way shortly to show how and why that equals 1, but at this point, it's much easier to simply look at the graph of this and realize it gets to 1 pretty quickly. So the limit as n goes to infinity of, and we call this one a sub n, is going to equal 1. Okay, and why is that? Well, we could simply look at our graph and then it went to 1. Okay, so let's look at our next one, and this one's a little tricky to see. All right, so we're going to go back, and I'm going to do parentheses 1 plus 1 divided by n. Parentheses caret to the n power. Okay, and this is one we really need to know. Okay, and when I hit graph, and this is one of the reasons why I actually took this out to 100, it does look like it's approaching a value. And this is one of the ones, by the way, we have to recognize. If I start looking at this, it's going to approach a value. And it may not get there very quickly, but it is approaching a single value. It's kind of hard to see on the screen here, but it's getting closer and closer. And if I would actually go to my table and look at it, and I'm going to do my table set and go up by a bigger number, let's say go up by 10 each time, and then go look at my table. Whoops. It slowly computes values, and I keep going out there further and further and further. Come on. Anyway, and what you're going to see it actually approaches is the limit as n goes to infinity of, in this case, b sub n. It's actually going to equal our friend e. Okay, because it gets very close to 2.718. It never is going to reach there in our window. Okay, but that's one of the ones we have to recognize, and we need to know that the limit as n approaches infinity of 1 plus 1 over n to the n is e. I know you may look at this and it's like, well, that looks, as n goes to infinity, this becomes 0, so I get 1 to the infinite power. What is that equal to? It's not 1, it is in fact e. Okay, and I can do a couple more values that'll slowly take care of it, but it's not getting there very fast, but it does approach e. Okay, and that's one of the ones you got to recognize. Okay, our last one, because of this, it alternates. Okay, so we're going to look at this one, and this will be our last one on this video. So if I go to y equals, and I'm going to do parentheses negative 1 to the n, okay, and then I'm going to make sure I do times, I have a parenthesis up top, and that's 2n plus 3 divided by n plus 1. Okay, I want you to think about this. It looks like this is going to 2, right? But this is alternating. So when we start looking at the graph, okay, it's not going to a single value, okay, because if I now hit trace, it goes positive, negative, it's bouncing back and forth. Okay, so what is that telling us? Is it approaching a single value? No. Okay, so the limit as n goes to infinity of c sub n, it does not exist. Why is that? Because it goes to two values. It goes either to 2 or it goes to negative 2. Is that a single value? No. Therefore, it does not what? Exist. Okay? All right, so that's the end of page 1. Hope this helps. Hope we understand what we did. And I can certainly answer any questions later. If you want to email me on that, that's fine too. Okay?